Welcome back, friends. Please remember that in this channel I usually post mathematical videos of a more advanced nature. So here we have a nice integral we're going to do, 1 over 1 minus sine of x. So how do we proceed here? When we have a rational function that involves a sine or a cosine or a combination of a sine or a cosine, we have to make a somewhat unobvious, let's say, or non-obvious substitution that says the following, that z is defined as the tangent of x over 2. We're going to begin with that. Now, this has specific consequences. If you take the inverse tangent on both sides here, then what will you have? You're going to have that tan inverse of z is x over 2. Now, this x over 2 is just basically the angle, and z is like really z over 1 right here. We got to see it that way, okay? Let's draw a triangle because this triangle will show us important information. So, draw a triangle that looks like the following, say. Okay. Here we are, nice triangle. So where do we mark this? X over 2. So the x over 2 would be pretty much right here, the angle. Okay. Now based on the tangent inverse of z over 1, that means this has to be z and this has to be 1. Which means by the Pythagorean theorem that the hypotenuse then has to be 1 plus z squared this way. This is what we have thus far. Now, let's continue. Since z is equal to tangent of x over 2, if you differentiate this part right here, say down below, then dz here is equal to secant squared of x over 2 times the derivative of the inside, which is just 1/2, with the dx right here. Now, let's solve this for dx. We need to do all of this to make a substitution in the end. So that means dz divided by secant squared of x over 2 is equal to, and then multiply the 2 over to the 2 dz here, so it's going to be 2 dz. This is equal to dx. Okay, so again, we have now a way to substitute for dx in our integral. Let's continue though. So what can we do next? Look at this shape right here, and secant squared of x over 2, we can very likely find it based on the shape. So secant would be just this, the hypotenuse over this leg right here. So we can make a replacement here. Let's do that over here. I'm going to say now that 2 dz right here, you're going to put that over not secant squared of x over 2 anymore, but simply 1 plus z squared, this quantity here, well, the root of it, that is, right, like this, squared. So replacing secant with this, and then the 2, and this is equal to dx. Now that we know this, of course, we can cross this off, right, like this crosses off with this, which means all that we have remaining, in fact, is just 2 dz over 1 plus z squared as dx. Okay, so we've made that step happen. Now, go back here. We've got a replacement for this part thus far alone, the dx. But what about the sine x? We got to get rid of that somehow. So we're going to use an identity that says that sine x, like this, is equal to 2 sine of x over 2 times cosine of x over 2. This comes, if you think about it, from the sum to product identities. If you graph the left side, if you graph the right side, you will see they come out to be identical, meaning that sine x can be replaced with 2 sine x over 2 times cosine x over 2. You'll see. Now, why would I do this? Because what this says is, look at the shape. We can find the following. This would be 2 and sine of x over 2. That would be just z over this quantity by the definition of the sine function. So it becomes 2 and then z hanging over the root of 1 plus z squared. And then the cosine, that just becomes 1 over the hypotenuse. So it's 1 over the root of 1 plus z squared. Now let's clean this up a little bit. Nice thing again is because there are 2 of these in the denominators. That means you're going to end up just with 2z, 2 times z times 1, and then these will cancel. So you're going to have 1 plus z squared. So now we can replace sine with this expression. We can replace dx with this expression. And we create our integral then as follows here. Let's do that at the next stage. So it's going to be the integral of 1 minus sine, but sine happens to take the form now 2z over 1 plus z squared, and then dx can be replaced with 2 over 1 plus z squared, and then dz. So we have recreated our integral. What do we have to do now? Well, we have to distribute, right? So like we have this expression in the denominator. You're going to take this 1 plus z squared right here and distribute to each term. So when we do that, we're going to have the following then, right? The integral here from 1, or 1 rather. So the 1 plus z squared goes over to the 1. That's going to give you a 1 plus z squared. And then this is going to go over to the 1 plus z squared, leaving only the negative 2z in this position. So minus 2z, okay, with the dz. Let's continue. So now, what happens next? Well, let's rearrange this. So it's the same as the integral. And this is 1 over now, let's see, z squared minus 2z plus 1 dz. That can be factored easily and rewritten then as follows, basically, right? The integral 1 over z minus 1 quantity squared dz. And of course, on this part, now we can just apply the power rule. So it just becomes, in other words, remember, z minus 1 to the negative second dz, like that. All right, continue. We're almost done. So apply the power rule to that. So we're going to have the following then. A z minus 1 to the negative first, because negative 2 plus 1 is negative 1, and the negative 2 plus 1 in the bottom is also a negative 1. We did a negative out here. And then attach your c. Continue, so negative. Let's recreate this then. We should not forget there's a 2 here. You see, I forgot that 2. So place that all the way out front here. There we are. So that means there's also a negative 2 out here. So negative 2, and then this is over z minus 1 plus c. Writing this as z minus 1 in the denominator. Now remember here, friends, that we define z to be this specific quantity here, correct? Right here, tangent of x over 2. So we want to make use of that here. It's going to be negative 2 over tangent of x over 2. Let's see, minus 1 plus c. And here the convention is to write this lastly as follows. Factor a negative 1 from each of the terms in the denominator and cancel with the negative in the top. You're going to have 2, and then once you factor a negative 1 out, this becomes a positive. Factor a negative from here becomes a negative tangent of x, like that. X over 2 plus c. And that's the answer. Friends, if you're into more advanced math videos like this one, please be sure to subscribe and like, and I will see you in another one.